Okay students, so now let us continue our problems of exercise 2.2. Clear? So already we have solved 4 problems in the previous class. Now I will go for the 5th problem, that is, let A be the set of 1, 2, 3, 4, 6. Let R be the relation on A defined by R equal to set of order pairs A comma B, such that A comma B belongs to capital A comma B belongs to capital A, B is exactly divisible by A. That means the second term is exactly divisible by the first term. That type of order pairs you have to select from set A. Okay. See, R equal to set of B is exactly divisible by A. That means the second term is exactly divisible by first term. So if I take second term as 1, now the A will be what? A term will be that kind of element which divides this one. So that's why 1 is always divisible by 1 but not with any other elements. Clear? So next, can I take 1 again? I can't take. Why? Because 1 is divisible by 1 itself, no any another number. Clear? Okay. So now I can take 2. Clear? Why? See here, 2 is divisible by 1. That means 2 can be divided by 1. Also 2 can be divided by 2, no problem. Clear? Next order pair. See, if I write 3 is divisible by what? 1. From the above set I am telling. So 3 is divisible by what? 1. Also 3 is divisible by 3 itself. Clear? So 3 is over. Is there any another number which divides 3? No. Clear? Okay. Next, see, if I write 4. So now 4 is divisible by 1. 4 is divisible by 1. No problem. Next, 4 is divisible by 2. No problem. Can 3 divide 4? No. 3 doesn't divide 4. But 4 is divisible by 4 itself. No problem. Clear? Now let us go for 6. So 6 is divisible by 1. No problem. Again 6 is divisible by 2. That means 2 divides 6. 6 is again divisible by 3. No problem. But 4 doesn't divide 6. 4 comma 6 will not come. 5 comma 6 will not come. 5 is not there. No problem. I can write 6 comma 6 because 6 itself divides. Clear? So these are the order pairs for your question number 5. That is, let A equal to be the set of 1, 2, 3, 4, 6. Let R be the relation defined by B is exactly divisible by A. B is exactly divisible by A. That means the number B has to be divided by the first element, that is A. For example, you can see here. For example, take 6. 6 is divisible by 1. 6 is divisible by 2. 6 is divisible by 3. 6 is divisible by 6. That kind of elements you have to select in the question number 1. That is, write R in the roster form. Clear? So next, domain of R, that is domain equal to, very simple, collect the first elements. What are the first elements? 1, 2, 3, 4, 6. Clear? 1, 2, 3, 4, 6. So this is domain, that is first elements. Next, what about range? Range is equal to, check, 1, 2, 3, 4, 6. So that is 1, 2, 3, 4, 6. This is range. Collection of second elements from the order pairs of R. Clear? So very simple problem, but this thing is very, very important. Here you have to be perfect. Clear? If this is perfect for you, then everything will be very, very easy. Clear? Okay, students. Now let us move to the sixth question, that is determine the domain and range of R. Okay, first let us write the R. After writing R, taking domain and range will be very easy. Clear? So that's why R equal to set of x value. If I take 0, y value will be what? 0 plus 5. So that is 5. Clear? Next, if I take x value 1, 1 plus 5, this will be 6. Clear? If I take x value 2, 2 plus 5, 7. If I take x value 3, 3 plus 5, 8. If I take 4, 4 plus 5. If I take 5. But see students, here what happens if I take, for example, if I take 1, it will be 1 plus 5, 6. Okay, here if I take 5, it will be 5 plus 5 and it is 10. Okay, so now domain equal to what? Collection of first elements. Clear? That is 0, 1, 2, 3, 4 and 5. Next, if I take range, what will be the range? Collection of second elements. 5, 6, 7, 8, 9 and 10. So this is range. Clear? Very simple question, but writing R is very, very important. Okay? Okay, students. So now, if I go on writing the relation R of the question number 7, what they have defined? R equal to x comma x cube, x comma x cube, such that x is prime number lesser than 10. No problem. Okay. So if I want to write R in roster form, I have to choose x as prime number lesser than 10. So first I can take the prime number as 2 because 2 is prime number. So here if I choose 2 as our first prime number, then x comma x cube, what will be 2 cube? That is 8. Clear? Next, if I choose 3, what is 3 cube? 27 because 2 is prime, 3 is prime. 4 is not prime. 5 is a prime number. So 5 comma it is 125. Clear? 5 cube is 125. Okay. So next, 6 is a not prime number. 7 is a prime number. So 7 comma 7 cube is how much? 49 into 7, that is 63, 28, 34, 433. Clear? So this much will be your R in the roster form. Next, 8, it's not a prime number. 9, it is also not a prime number. And all the numbers lesser than 10 are over. Clear? So 2 is prime, 3 is prime, 5 is prime, 7 is prime. Please remember students, prime number means the number, for example 5, it is divisible by itself and 1. It is divisible by itself and 1. Okay. So that's why 5 is called prime. 7, it is also divisible by itself and other number is 1. Clear? 23, 23 is not divisible by any number. It is divisible by itself and 1. Clear? Such type of numbers are called as prime numbers. Okay. You can also take 29. 29 is a prime number. It is divisible by itself as well as 1. But no any other numbers divides 29. No any other numbers divides 5. No any other numbers divides 23. Itself and 1. Leaving itself and 1. That's why 29, 5, 23, 3, 2, they are all called as prime numbers. Clear? So here lesser than 10 means 2, 3, 5 and 7 are the 4 prime numbers, and the cube of 2 is 8, cube of 3 is 27, cube of 5 is 125, cube of 7 is 343. Clear? Okay. Let us go for the next problem. Students, now let us go to the 8th question, that is, let A equal to set of x, y, z and B equal to set of 1, 2. Find the number of relations from A to B. Clear? Okay. As you all know, formula for number of relations is number of relations equal to what? 2 to the power of PQ. What is 2 to the power of PQ? P is number of elements in set A. Q is number of elements in set B. Okay. So if I use this formula, what you are going to get? 2 to the power of P is 1, 2, 3. 3 elements. Q is 1, 2. So that's why this is 3 multiplied with 2. Therefore, 2 to the power of 6. Clear? So we all know that 2 to the power of 5 is 32 and 2 to the power of 6 will be 64. That means 64 relations I can define from set A to set B. Are you clear? So we all know this formula. If you don't know, now you write down it and please remember that formula. Very, very important. 2 to the power of PQ. 2 to the power of PQ means P is the number of elements in set A. Q means the number of elements in set B. So 2 to the power of PQ is 2 to the power of 3 into 2, that is 2 to the power of 6, that is 64. Okay. Let us move to the last problem of your exercise 2.2. Students, let us see the 9th question. Clear? Here, what they are asking, let R be the relation on Z defined by R equal to order pair A comma B such that A comma B belongs to Z. Z means integers. A minus B is an integer. Okay, students. So here, if I go on writing it in roster form, each and every problem I have written in roster form, but if here I go on writing in a roster form, it will be an infinite set. Why it will be an infinite set? Please see here. A comma B belongs to what? Z. A comma B belongs to what? Z. Z means integers. So A is also integer, B is also integer. As you all know, if we take two integers and if we add, subtract or if we multiply, they are going to be again an integer. It's a basic concept of mathematics. Clear? If we take two integers and if we multiply, add or subtract, again it will become an integer. For example, 2 minus 3 minus 1. 2 is integer, 3 is integer. If I subtract 2 minus 3, I will get minus 1. Minus 1 is also integer. If I take 2, if I multiply it with 3, 2 into 3, 6. 2 is also integer, 3 is also integer, 6 is also integer. Like that, here what happens? Integer set is infinite set. So, order pairs will go on becoming infinite elements. Order pairs will become infinite elements. So, all those things cannot be written in the roster form. So, for that purpose, I will directly write domain and range. Anyways, they have not asked the roster form. No problem. Directly they have asked domain and range. So see here, the collection of first elements is domain, the collection of second elements is range. Both are belongs to integers. That means domain is going to be equal to integer set z, range is going to be equal to set integer. Clear? So domain is an integer set, range is also an integer set. Roster form, if you want to write, you can try. The order pairs are not going to be end because they are infinite. Clear? So for that's why domain is z, range is z, this much is enough. Don't try to list all the order pairs because they are going to be definitely infinite and they are not going to end. Okay, here ends your relations topic. So we already completed Cartesian product of two sets. We already completed Cartesian product of two sets. That means we have covered nearly 60% of our chapter now. Cartesian product is over, solved examples on Cartesian product is over, exercise 2.1 on Cartesian product is also over. Clear? Next, after that we gone through relations. If you want to study relations, you must have a clear idea of Cartesian product. So that's why first we studied about Cartesian product, then we came to relations. We have studied the relations on the definition of Cartesian product. We also solved some of the solved examples. We also solved the exercise on the relations, that is 2.2. Now we will go to functions. So here, if you want to understand functions topic, relations must be very perfect. Are you getting my point? Because functions topic is based on relations definition. Okay, if you know what is relation, then you can define what is function. If you know Cartesian product, then you can define relation. If you know relation, then you can define function. They are all interrelated to each other. Okay, so for that reason, please make sure that before going to functions, watch all my previous videos again and again for more and more understanding of the basic concepts, because functions is a very important topic which deals you with the calculus topics which you are going to study in future. So by starting only, if you start with the good approach to the functions, it will be very good approach to the calculus part. So that's why, because in mathematics in the future, calculus is going to play a very, very important role. Without calculus, there is no mathematics. Without calculus, you can't pass your any second year syllabus or second year board exams. So that's why functions is going to play a very important role. That's why I am telling, make a perfect that functions topic is very much understanding to you. Okay, if you don't understand, you watch the videos, you ask the questions, you do something, but without understanding, don't put a step forward. Without understanding the function, don't put any step further. Clear? So first understand the functions topic, then you move on, because that functions topic is a door for your a very big concept, that is calculus. Okay, so that's why I am telling, please be very much sure about watching the videos. Okay, so now let us start functions. Okay, students, now let us start a very important topic, that is functions. Clear? So before going to function, as you all know the definition of Cartesian product and relation. Clear? For example, if I take set A as 1, 2, 3, set B as 4, 5, 6. Now I ask you to count how many number of relations you can define from set A to set B. Already this type of question you have solved in the exercise 2.2. Clear? Here again I will take one of the example so that for understanding the function it will be very easy. Clear? In A you are getting 3 elements, in B you are getting 3 elements. If I calculate number of relations equal to, see, how can you count the number of relations? 2 to the power of PQ. P means number of elements in A, number of elements in B. So 2 to the power of 3 into 3 is 9. That means 2 to the power of 9 relations you can define from set A to set B. Please understand it. You can calculate in Calci what is 2 to the power of 9. That much number of relations are going to be defined from set A to set B. Are you clear? Then why I am explaining this much about relations? Why? Because these functions are hidden in this relation. ಈ ಫಂಕ್ಷನ್ಸ್ ಅನ್ನೋದು ಎಲ್ಲಿ ಹೈಡ್ ಆಗಿರುತ್ತೆ ಅಂದರೆ ಇದರಲ್ಲಿ ಇರುವಂಥ ರಿಲೇಷನ್ಸ್ ಅಲ್ಲೇನೆ ಆ ಫಂಕ್ಷನ್ ಇರುತ್ತೆ. ಅದು ಯಾವ ರೀತಿ ಇರುತ್ತೆ? ದಟ್ಸ್ ದ ಕ್ವಶನ್ ಮಾರ್ಕ್. ಕ್ಲಿಯರ್? So, if you understand the definition of function, then you can select those relations in this 2 to the power of 9 which are hidden in this relation. Those things are going to be the function. ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಈ ಫಂಕ್ಷನ್ ಡೆಫಿನೇಷನ್ ನಿಮ್ಗೆ ಅರ್ಥ ಆದರೆ ನೀವೇನು ಮಾಡ್ಬೋದು, ಈಗ 2 to the power of 9 ಅಂತ ನಾವು ಏನು ನಂಬರ್ ಆಫ್ ರಿಲೇಷನ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದೀವಿ ಅದರಲ್ಲಿ ಇರೋವಂಥ ಸಮ್ ರಿಲೇಷನ್ಸನ್ನು ನೀವು ಪಿಕ್ ಮಾಡೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಾ. ಏನು ಪಿಕ್ ಮಾಡ್ತೀರಾ? ಆರ್ ಪಿಕ್ ಮಾಡಿರುವಂಥ ರಿಲೇಷನ್ಸು ಫಂಕ್ಷನ್ಸ್ ಆಗಿರ್ತವೆ. ಆರ್ ಗೆಟಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? ದಟ್ ಮೀನ್ಸ್ ದೇರ್ ಆರ್ ಸಮ್ ನಂಬರ್ ಆಫ್ ರಿಲೇಷನ್ಸ್ ವಿಚ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಎನ್ ಅ ಫಂಕ್ಷನ್. ಸೊ ಹೌ ಮಸ್ಟ್ ಬಿ ದಟ್ ರಿಲೇಷನ್ ಟು ಬಿ ಎನ್ ಅ ಫಂಕ್ಷನ್? ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಕ್ಲಿಯರ್? I will draw a map diagram or arrow diagram, or we say it as a mapping from set A to set B, or we call it as a map or mapping or arrow diagram. Clear? Now I will start with arrow diagram. In that some arrow diagram will become a mapping. Why they will called as mapping? Those arrow marks who are going to be in a mapping, those things are going to be in a function. Those will remain as an arrow diagram, that things are not going to be in a function, because for functions we call mapping from A to B, for relations we call arrow diagram from A to B. See, this all are very very important informations. Okay, now I will draw one arrow diagram first and let us check is it going to be in a function or not. Okay, I will choose 1, 2, 3, 4, 5, 6 and I will define a relation. Which type of relation? 1 goes to 4, 2 goes to 4, 2 goes to 6, 3 goes to 5. This is one arrow diagram. I will go for the second arrow diagram. 1, 2, 3, 4, 5, 6. 1 goes to 6, 2 goes to 5, 3 goes to 4. Clear? This is another mapping. Another arrow diagram. A to B. Okay. I will take one more here. 1, 2, 3, 4, 5, 6. 1 goes to 4, 2 goes to 5, 3 goes to 6. Okay. Now I will tell one hint to understand the function. To understand you in a function, I will say one hint. What is that hint? This is not function. This is not function. Okay. This is function. Clear? This is function. Clear? That means these two are going to be in a functions, but the first arrow diagram is not going to be in a function. Please pause the video and observe those arrow diagrams. Observe those arrow diagrams. What is the difference between these two and this arrow diagram? So that yourself you can understand what makes the relations to be an a function. What makes relations to be an a function? What is that condition? You will understand yourself if by observing 1, 2 and 3 arrow diagrams by pausing this video. Try. You pause the video and you try first. I will explain. That's the further thing. But you pause the video and try. What is the difference observations between these 3 arrow diagrams? You check. Okay. So what is the difference in this arrow diagram means there is one element in this arrow diagram which is having 2 images. Which is having 2 images. That means see this 2. It is having 2 images. One goes to 4, another goes to 6. That means 2, 4 and 2, 6 is present in this. Other things are 1, 4, 3, 5. Other things are 1, 4, 3, 5. But these 2 order pairs will not be a condition for function. That means these 2 order pairs are making a problem for this relation to be a function. Why it is making a problem? Because it is having 2 images. Check in this. There is no element which is having 2 images. Check in this. No element is having 2 images. That means if the relation has to be in a function, from non-empty set to non-empty set B, the every element of set A, please understand this, the every element of set A must have an unique image. That means every element of the A must not have 2 images. Unique means 1. That has to be only 1. Clear? One more thing. Suppose if I take 7 here, if I put 7 here, then also this thing is not going to be a function. Here this is also not a function. Why? Because what definition tells every element of set A. But here if I introduce 7, this 7 is not having any image, then what happens with this? This will not become a function. This is the second important condition. Clear? First one is all elements must have unique image. And if there is an element which is not having any image, then also it is not a function. Clear? So that's why please remember this. Each and every element of set A must have unique image to become a function. If the relation has to become a function, each and every element of set A must have unique image in set B. One small point to remember. If I introduce 7 here in the set B and if I take 7 in the set B, there will be no problem. It will be in a function. But this 7 has to be not in A. A 7 ಅನ್ನೋದು A ದಲ್ಲಿ ಇರಬಾರ್ದು. B ದಲ್ಲಿ ಇದ್ರೆ ನಮಗೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ? ಯಾಕೆ ಅಂದರೆ A ದಲ್ಲಿ ಇರುವಂಥ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗೂ ಯೂನಿಕ್ ಇಮೇಜ್ ಇರಬೇಕು. ದಟ್ಸ್ ವಾಟ್ ಫಂಕ್ಷನ್ ಡೆಫಿನಿಷನ್ ಟೆಲ್ಸ್. But function definition never bothers about the elements of set B. That's why please remember, if this 7 puts in A, then it will not be a function. But if it is in B, no problem. Clear? So that's why you remember that small idea. Okay, that things are not explained in any definition or in any textbook. That we have to understand. By understanding that short type of things, you can increase your knowledge. That type of things will never be explained in any textbook. Okay, so that's why you have to understand that very carefully, because what function definition tells, again I will explain you. A relation from set A, or a relation from non-empty set A to non-empty set B to become a function, each and every elements of set A must have unique image in B. Must have unique image in B. Clear? If they are having a unique image, definitely that relation is going to be a function. So now I will write the definition on the board so that you can take notes of that by pausing the video. But you first make sure that you are understanding the functions definition. Please don't by heart. Please don't by heart any definitions. Understand the definitions. Understand the logic behind the definitions. Then only you can grow in mathematics. Then only you can approach very easily to the problems in mathematics. Clear? Okay, I will write down the definition on the board. You try to take a notes of it by pausing the video. Clear? Okay students, now pause the video and try to take a note of this. That is the definition of function. Clear? So here see what they are telling. As I explained previously, a relation f from set A to set B is said to be function if every element of set A has one and only one, that means unique, one and only one, nothing but unique image in set B. That's all. Already I have explained with the arrow diagrams clearly how the relations is going to be in a function. If you want, you take a notes of that arrow diagrams also with this definition, so that whenever you are going to make a revision, that time you are going to understand a function clearly, so that there will be no doubts. Okay, so pause the video and you take this definition of function.